Hey everybody, John Grimsmo here, and today I want to talk to you about patterns, specifically our new flatland pattern. This is something I've been working on for a little while. Been thinking a lot about patterns, ways to spice things up. This one is super cool. So I first came up with this when I started making these lapping plates, these cast iron lapping plates that we use for hand lapping flat surfaces, like really flat surfaces. So I made 6-inch ones and 8-inch ones, and I have this triangular grid pattern, and it turned out really good on those parts, and I was like, I need to see that on a Norseman. So I made this a couple months ago, and the guys tumbled it and anodized it, and so I anodized the lines blue, tumbled the whole thing again so the rest is silver, and it turned out awesome. But we didn't have the lock side done, and I wanted to get the lock side done. So the other night I spent some time in Fusion, and I got the lock side done, and I'm pretty happy with how this turned out. I wanted a border around the outside of everything, and I wanted a bit on the lock bar with a border around the outside, and I think it turned out great, except they didn't work. They didn't finish properly. Check this out. So first of all, the pattern is shifted. It is lower than it's supposed to be, and it's like that on both handles. So they're mounted in the machine like that, and the whole pattern in this orientation is shifted to the right compared to where the handle's supposed to be. So that's not right. And just makes it look kind of silly. And it put a chamfer on the outside, not a corner rounder, and it didn't finish these holes and didn't finish those holes, and it's missing some details. And I know my problem. I know what I need to do wrong. But for first test, it looked really good. It turned out really good. And how about we jump into Fusion, and I'll show you how I pulled this off. So in Fusion, I have our Norseman center palette. And here you can see the pattern is kind of centered and shifted. And what happened is, my origin's way up here, and I think it's in the wrong position. I think I need to look further. Like if you see over here, it's going to take too long to open it up. But normally we have this like 20-inch long orange vise palette that a fixture origin is in the corner, and I'm cheating here. I've kind of created a new file with just the center palette, and I got something wrong. So I need to investigate why it shifted. Not a big deal. But technically speaking, let's go into the design side first, and I'll show you. I've got patterns folder, I've got triangles, lock side handle, and display side handle. I've got a pocket clip mounted just so I could see. One question I had is, do I put the pattern on the pocket clip? It gets a little messy with the logo being right there. I don't know. So let's ignore the pocket clip for the moment. So we'll work on the display handle. We'll hide the lock side for now. This display I actually did model. What do I want here? I modeled the pattern, and honestly, modeling a pattern it's cool because then it looks cool, but it's not worth the time most of the time. When you're just going to be machining the part, sometimes drawing a sketch and letting the CAM simulation show you what it's actually going to look like is way faster, way more efficient, and less hair pulling than actually trying to model it and make it look right in the model, which for my purposes doesn't have a lot of value. Because it takes a long time to model this and have it to go right. But let's see, I'm trying to remember how I do this. So I've got some sketches. I've got my triangles from top, and this is my 5.7 diameter. So this is how I did the pattern on the lapping plates, on the 6-inch lapping plates. My lines are spaced apart 1/4 inch, and then I just rotate that pattern 3 times around a circle so that you get triangles. And then what I did from there is, this sketch right here is how I do that groove around. So that gets swept around the outside, around this way, around a, there we go, profile sketch around this line, or there's another one I'm missing. In this folder is probably where the answer is. Yeah, handle, outline, and geometry. So I have one line going, around my profile where I want it to be, and then I have my machining lines where I took, if I hide the body, so there we go. So this is my machining sketch basically, where I took this pattern And I drew my outline around the outside, and then I trimmed it. I used the trim tool, or T for trim the outside, and then in the cam side, I just select every single line. It's not that I'm drawing little triangles, it's that I'm drawing straight lines going all the way across. And that's how the tool moves too. The tool moves all the way across. And then for the lock side, I did pretty much the same thing. Triangles, lock side, sketch, machining sketches right there. So that is all good and dandy. And you make sure that everything is connected, every point is connected so that it's a continuous curve around the outside. There's even a little tiny one here, and I'm like, yeah, let's leave it. It's probably, actually, let me look at it. That is, yeah, you can kind of see it. It just needs to be there. I chose not to ignore the pocket clip, like go around the pocket clip and stuff. I'm just patterning all under it. It should be fine. So if we jump into the manufacturer side, so here I have my model, and I have my machining sketches, and I have 3 sets of folders. They're not patterns, they're just folders to contain everything. When you're cutting a fine detail with a ball end mill, and if you just drop it down and plow it through the material, it's going to look really good on one side and really gross on the other side, because you're climb milling on one side, zip, 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 and you're conventional milling on the other side, which is zipping in the wrong direction, so you're smearing. And if you just drag it right through the center and you're looking for like perfection and shiny and accuracy and stuff, it looks gross. So usually what I'll do is I'll drag through the center once, I'll step over 1 thou or half a thou or something, climb mill that wall, step over on this side, climb mill that wall. It takes 3 times longer, but it looks good. It looks really good. And that's what I ended up doing here. So that's why I have 1, 2, 3 folders that pretty much do the same thing, except they're shifted off by 5/10. So if we have our outline here, and now I'm doing both handles, both patterns in the same setup. So this is my outline. And if I look at the properties, there is no stock to leave. If I do the second folder outline, there should be plus 5/10 stock to leave. Third folder outline is minus 5/10 stock to leave. So drag down the center, second op on the left side, third op on the right side. And the same thing, so that's my outline. So I have 3 lines. Remember, these are straight lines that I'm cutting. So 1 side, 2 side, 3 side. So lines to the right, lines vertical, and lines to the left. And then same thing over here. This line will be plus 5 thou, and the third line will be minus 5 thou. So this whole pattern, as programmed with a 2-flute, 10 thou radius Lakeshore Carbide engraving tool, 2-flute, takes 1 hour and 11 minutes. That is so ridiculously long for a pattern. A lot of our patterns take 10 minutes, 20 minutes, 30 minutes, something like that. 1 hour to draw some lines is ridiculous. So over time, I might experiment with different end mills, floor flute end mill, something like that, or just crank them faster and see if the tool doesn't break. This 10 thou end mill breaks very easily, so I have to be careful, which is why I'm going so slow. Speeds and feeds are 12,000 RPM, max it, which only gives me 62 surface feet, and then 6 inches per minute, which is quite slow, giving me a 0.00025, like 2/10 chipper tooth, which is very low, but that first pass especially, I'm dragging through the middle. I can't overload that 10 thou ball. And I'm pretty sure on second op and third op, yeah, I'm going much faster. So I'm going 7/10 per tooth, 18 inches per minute instead of 6, because I'm not dragging anymore. I'm just kissing the side. So I can kiss the side 3 times faster and totally get away with it. I'll probably go even faster. But you start going too fast, and then you see like doop, 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 doop. You see these swirls, your feed per revolution, basically. Your feed forward lines, that's what I called. But yeah, that is how we do that. And overall, except for the offset being wrong and the rest of the features not being cut properly, I think it turned out really, really, really cool. And what's also really cool about the pattern is how it shimmers. See, this is why we put the effort into cutting the tool path 3 times is because then each surface, left surface, right surface, bottom surface of that engraving is shiny, because otherwise it gets kind of dull on the one side. And the way it shimmers in the light, this isn't the best lighting for that, but it's showing, look at that. When you want it to do that, when you want it to be optically like gorgeous, you put the effort in. You just do. And I can probably speed it up and have it not take an hour, but for now, I'm just going to send it. Anyway, once it's on the lock side, it's going to be sick. There you go. New pattern, coming soon. I'm calling it the Flatland pattern because those flat lapping plates, they make parts very flat. And I just thought that was really cool. Cool name. So naming stuff is always weird. You just kind of make it up and let it stick. But yeah, so hopefully once I fix the offset shift, we're going to start making a couple of them, more of them, and then see what the finishing guys and the anodizing team like does it with it, because there's a lot of cool options you can do with something like that. And that's about it. All right, guys, thanks for watching. Later.